All right. Some of us had a really wicked, weird day trying to work on these logarithmic equations and making sure that we were able to solve these correctly. I want to go over the goals really fast so that we can move on to, and I'll move the camera a little closer so you can see what this says on the board. I want you to be able to understand. We want to have one log with the same base or one exponential with the same base on each side. That way we can just set these guys, either the powers equal to each other or the arguments equal to each other. But when I say that, it's the same thing. Sorry, here we go. And we're going to use algebra to do this, to get ourselves there. And I'm going to show you what that means. So if you don't mind, I'm going to move this closer, and I've got to, sorry about moving the whole thing. I'm just going to slide this over, and then we should be good. All right. So my first problem is, right, what was my goal? My goal was to have logs with the same base on either side of the equal sign. So these two logs, these are common logs. They have a base of 10. So they are the same. So when they have the same base, all we have to do is set these arguments equal to one another. So 4p minus 2 is equal to negative 5p plus 5. Okay, now I'm going to get all my p's over here, all my constants over there. So plus 2 plus 5p plus 5p plus 2. All right, so my 2 is gone from here, and I have 9p over here, and then that goes away, and then 5 plus 2 is 7. 9p equals 7. Of course, we divide both sides by 9. And p is equal to 7/9. I know you don't like fractions, but that's how it is. That's the way it goes. We have to be able to do this. So that was the first thing. The first thing I said, have the same base, and then we can move on and solve. Here's the second part. This is number 2. Use your algebra to get you to a logarithmic equation. Then transfer that logarithmic equation, convert it into an exponential equation, and then we can solve. Here's what it looks like. I have negative 6 log base 3 of x minus 3 equals negative 24. Well, what do? I have some multiplication that I need to get rid of first. So divide this whole thing by negative 6, divide this side by negative 6. Now I have log base 3 of x minus 3 equals, well, negative 24 divided by negative 6 is 4. Oh, now I have a logarithmic equation. Now I can convert this by, of course, switching places with the 4 and the x minus 3. Give me an exponential equation where this is my power and this is my argument. Okay, now 3 to the 4th is equal to x minus 3. Well, that I can solve because I know what 3 to the 4th is. 3 to the 4th is 81 equals x minus 3. Going to add 3 to both sides to isolate this variable. And we have 84 is equal to x. Great. That's our second one. There's our first one. Moving on. Now, I have arguments on both sides with the same base, right? And remember, common log, if it doesn't have a base here, it's just base 10, but we don't need to know that right now. All we're going to do is we have a log and an argument on either side, so I can just set these arguments equal to one another. And what we're going to end up with is a quadratic. And the reason I left so much room here is because I'm going to have to check to see if my answers are valid answers. I'm going to look for something extraneous. So 16 plus 2b is equal to b squared minus 4b. All right, I want everything over on this side. I do. That's exactly what I need. So I'm going to subtract 16, subtract 2b, and what do I get over here? I get 0. Minus 2b minus 16. I'll leave it over there so we have columns, and that's going to be equal to b squared minus 6b minus 16. Excellent. Are we ready? We can factor this guy, right? What factors of 16 have a difference of 6? Of course, it's 8 and 2. So I'm going to say this is b minus 8 because the minus has to be by the larger value there. And then b plus 2. Well, what number minus 8 equals 0? B is positive 8 or negative 2. Let's see if these both work. I'm going to put an 8 in. 16 plus 16, right? So I go 16 plus 2 times 8 is equal to 8 squared minus 4 times 8. Right? So 16 plus 16 is 32. Is equal to 64 minus 32, which is 32. The 8 checks out. All right, well, let's try it with negative 2. 16 plus 2 times negative 2 is going to be equal to negative 2 squared minus 4 times negative 2. Okay? And 16 minus 4 is 12. 16 minus 4 is 12. Is equal to 4 plus 8, which is 12, right? So 12 is equal to 12. Both are valid solutions. Great. I know. It's a lot of work to do all this, but that's what we got to do. All right? So take your time. If this is too much in this video, don't worry. Don't worry so much. Go back, look at it again, slow it down, whatever you have to do to get this. All right, here's the very last one I'm going to do, and this is condensing so that I have one log of the same base on each side and then I can solve for its arguments. But we have some subtraction here, so I'm going to have to condense. Right? And remember, subtraction condenses to division. So here we go. Log base 9, x plus 6 minus log base 9 of x. I'm going to write it as 1 log base 9, and I'm going to divide x plus 6 by x. And that's going to be equal to this side, log base 9 of 2. Now I'm done. I don't have to rewrite it into an exponential equation. I can really just solve these arguments. So I have x plus 6 divided by x equals 2. I multiply both sides by x. Multiply both sides by x. And I get x plus 6 equals 2x, right? Because that cancels with that. There's no denominator there anymore. And then all I'll have to do is subtract an x from both sides. And x is equal to 6. That's it. Those are they, man. These all work out. That's what we're going to have to do. Not a big deal. It's not too difficult. Go back over this. We're going to do more and more and more. We'll throw some natural logs in there. Euler's number will rear its ugly head, but we'll get through this. Don't be upset, but go back, take a look, See what happens. What disappeared? Oh, these logs disappeared because they have the same base, so we're just solving for the argument. Oh, well, what happened over here? I rewrote, look, I had one log here. I could just create a logarithmic equation and then rewrite it in exponential form and then solve for the variable. And then again, just like before, this was just a little bit more extensive, right? I wasn't just solving two binomials. I was creating a quadratic and factoring that quadratic. And then last but certainly not least, this is what I did. I had the same a log with the same base. It just so happened that it was division, and I just solved my arguments. Okay? It's all good. You're going to be great. Thanks for watching, but really watch this. Get used to it. I know it's annoying. It's long. This is 4 problems. Now, maybe I talked about it a little bit extra, but it's 4 problems, and we took a good 11 minutes just for this, okay? So please work hard, and I'll see you tomorrow.